Hi class, this is Mrs. Juliana again. We're going to do day 2 now with CPCTC. So CPCTC is a little acronym. They call it an acronym, and it stands for the fact that corresponding parts in these triangles, so that means side BC and side EF, are congruent. Or AB is congruent to ED because they're corresponding sides. And AC is congruent to FD because they're corresponding sides. So with them all being corresponding sides, then they have to be congruent. And that's all that CPCTC stands for. You might say, well, that makes sense. And of course it does. CPCTC stands for corresponding parts of congruent triangles are congruent. All right, now notice that you have corresponding parts first, and then congruent triangles are congruent. The two second C's are congruent C's. All right, those are saying that congruent triangles parts are congruent, so those are congruent, but it always starts with corresponding. And so sometimes people forget that. So I just wanted to point that out. Starts with corresponding, then corresponding parts of congruent triangles are congruent. All right, if we know two triangles are definitely congruent, such as these two here, then we absolutely know that every pair of corresponding parts is also congruent. So that means I know for sure that every angle has a congruent angle, its corresponding angle will be congruent, and every side has a corresponding side that's congruent. So that's what CPTCT stands for. We're going to do a few examples here. And a lot of times they're going to ask us to actually list those corresponding parts that are congruent. So because triangles have three sides, then that means we have to list three sides that are congruent to their corresponding three sides, and that each of the angles have to be congruent to their corresponding angles. So if we have a corresponding congruency statement, then that's even better. That's so nice because you can just look at it. You don't have to go from triangle to triangle and see if it's been flipped or rotated or anything. It's just they're listed in order for you to just draw from. So angles, if we have angle J, then we know angle J is congruent to whatever is in the same position over here, angle P. All right? Then we know angle K and Q because they're second in position there. Angle K would be congruent to angle Q. And then the third of the three angles, L and R, will be congruent, and they're corresponding. So angle L corresponds to angle R, and therefore they're congruent. Now, notice that the angles are written in front. We have to have the angle there because that represents an angle, and because they're so easily spotted, then we have to make sure we put the angle. All right, sides. Now this is where we have to look at the first two, so JK and then PQ. The first two in each of the two triangles are JK, and it's a side. We're going to call it segment JK is congruent to segment PQ. So we write our segments out there. All right, that's our one. We just take the first and second angles, and then K and L and Q and R. So KL is congruent to QR. I'm just going to go ahead and put those segments on after. And then the last one, I'm not going to draw a segment over because it's the first and last of the angles. So J and L, and then P and R. So JL is congruent to PR. All right, with those three sides being congruent and those three angles being congruent, then those properties exist for two congruent triangles. So that's pretty nice. So if I were asked to write another valid congruency statement, that just means I'm going to mix up the order of the first triangle. So triangle, I don't know, let's go backwards, LKJ, and we would write congruent to triangle. Now notice we have triangles out front. That's to distinguish it from an angle, because we could have angles, we could have triangles. So we have to make sure when we're writing a congruency statement that they are triangles that happen to be written in front of the LKJ. So LKJ, that means I have to go exactly in the same order, backwards, RQP. All right, and that would be another valid congruency statement. Now, just for fun, I'm going to do one more just to make sure you got it. What if we went KJL? KJL. What would that be congruent to? Triangle. So we start in the middle, Q, and then go back to P and then to R. QPR, to make sure that they're in the right order. So those are both two valid congruency statements there. All right, that's one example that you'll be working on. Example 2 gives us another option here. You're given that triangle KPM is congruent to triangle AYC, and you're to complete each of the following statements. So KM would be congruent to what? So if I say KM up here, I'm probably just not going to look at these right at the beginning, even though I know they're congruent. I mean, I could, KP is congruent to AY, right? See how they're flipped? I'm going to go ahead and do that. KP is congruent to AY. Then PM is congruent to YC. So that's PM is congruent to YC. And we can give that a double dash because those two are congruent. And then KM, notice that's first and last, and then AC, first and last. Okay, those two are congruent. Give them a double mark. All right, we can go back and do angle K and A, and then P and Y. We'll give a double arc to distinguish that those two are corresponding angles, therefore congruent, and then M and C. So M, we can do 3 marks, and C, 3 arcs. And that will at least give you the corresponding parts visually so that you can see them. But I wouldn't go off of that because you can see that they've been flipped and then also rotated. And then it's a little more confusing. I would go strictly from this lovely congruency statement here. It's going to be more helpful. So if I look at KM, side KM, notice it's a side on top, so that one's a side. KM and AC would be congruent, right? And then CY, if I look at CY, I have to go in the exact same order. So first, then second, or third, then second, sorry. M, then P. So MP. And again, order matters. So PK, so P to K, so it'd be Y to A. Yeah, all right. And then if I look at angle Y, now I'm down to Y angles. See, these 3 are angles, whereas these 3 were sides. So angle Y right here is second, so it's going to be congruent to angle P. All right, just make sure you get the angle in front. And then again, angle K is first. So on the other triangle, A is first. So angle K will be congruent to angle A. Now, this is a typo. It should just say ACY. So ACY is the angle. So if you look over here, it's ACY. It's the 3 marked one, A to C to Y. But I have to go 1 to 3 to 2. So on my triangle, I have to do the same thing, 1 to 3 to 2 on the other one. So KMP, angle KMP. Now, angle KMP, if I look up here, ACY, ACY, and then KMP are in the same order. So it will match for sure the triangles that are congruent, the corresponding parts, but it's just easier instead of going to a triangles to go to here. But you can do it whichever way you feel most comfortable doing. Now, these last 2 are triangles, and they're going to be just congruency statements. So we have to mark the correct triangles in the same order that the angles are congruent. So MPK is backwards, so we need to go backwards on the second triangle, SIA. We write in triangle, and then SIA. Make sure you put in the triangle. And then YAC, YAC, PKM. Triangle, PKM. All right, so be careful with those. But that's your little congruency statements. Woo-hoo. All right, next example 3, you're going to get some problems like this on your homework. I'm going to go ahead and zoom back out so you can see the whole problem here. So triangle DEF, if you look at that, and triangle JKL are congruent. All right, now what I would do on these is I would just go ahead and draw myself 2 congruent triangles. So DEF, and I would put them in the right orientation, DEF, and then JKL. See how I started down, up, down, JKL in both cases. That allows me to say, oh, these 3 sides correspond to these 3 sides, and these 3 angles correspond to these 3 angles, which is a lot easier. And if you'd like, I kind of like them color coordinated. I'm just going to quickly color coordinate the sides that are congruent because a lot of times it's easier to look at that when I'm setting up my algebra. Find sides or angle measures. All right, so DE is 18, so from D to E is 18. And then E to F is 23. So there's E to F, 23. And then DF, where's DF? Right here is 9x minus 23. And then JL on the other triangle, JL is 7x minus 11. JK is 3y minus 21. And then find the values of x and y. So this helps me see it. And once I see it, then it's much easier for me to find x and y using my algebra. If you're looking for x, and then we're looking for y, just write those out so they're separate. Finding x. So I find, ooh, these two statements have x in them. Oh, and look, they're congruent. All right, so they have the 3 marks in the same color, so they're congruent, so I can just set them equal to each other because they're corresponding sides. 9x minus 23 equals 7x minus 11. And I'll subtract 7x from both sides, and I get 2x minus 23 is equal to negative 11. And then add 23, and that gives me 2x is 12. X then is 6. All right, found that one. Now to find y, I see y is in this statement here, this expression. So 3y minus 21, I just need to find what it's equal to. And of course, it's equal to its corresponding side, which is 18. So I can set 3y minus 21 equal to 18. And then add 21. So that would be 39. And then y is 13. All right, when I divide by 3. So there is what you would do to find x and y. All right, that completes the notes section. So now you have 1 page of homework. It's 16-1. It's on the next page. Have that done. Good luck with that. And then tomorrow I'll start with my next section and get your next videos in for you to do that next. Have fun with homeschool with Mrs. Juliana and online school. See ya.